Welcome to the 6.3 video lesson. This is proving that a quadrilateral is a parallelogram. So in this section we have 3 different objectives. The first one is you can find values that will make a quadrilateral a parallelogram. The next one is you can decide whether a given quadrilateral is a parallelogram. And the last one is you can prove that a quadrilateral is a parallelogram. So the first thing we have to do is we have to recall some specific properties regarding parallelograms that we just learned in the last section. So I've got 4 properties here. Make sure you have these in your notes. These are 4 very important properties. First one, consecutive angles are supplementary. So remember, my consecutive angles are ones that are directly next to each other, and they're going to be supplementary, or 180 degrees. Opposite angles are congruent. Opposite sides are congruent, and because it's a parallelogram, they're also parallel, and diagonals bisect each other. That's the one property that we learned in class, so you might not have that in your notes. So please make sure that you put it in your notes now if you haven't done so already. So now we learned a lot of theorems last section. That's what led us to each of those different properties. Well, today we're learning the converse of each of those theorems. So, for instance, Theorem 6.8 is the first theorem we'll talk about, and it's the converse of 6.3. So, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Theorem 6.9, if an angle is supplementary to both its consecutive angles, then it is a parallelogram. So all of these theorems are telling me if this is true, then I have a parallelogram. That's where the whole proving parallelogram thing comes in. Theorem 6.10. If both pairs of opposite angles are congruent, then it is a parallelogram. And Theorem 6.11. If your diagonals bisect each other, then it is a parallelogram. In other words, if a quadrilateral has any of the properties of a parallelogram, it is one. If it has the properties, then it is a parallelogram. That's the plain and simple. But please make sure you have each of these theorems down in your notes, because we do need to know that these are properties and they will prove a quadrilateral is a parallelogram. On this slide, I'm going to go ahead through and I'm going to look at some different examples. For this first example, it asks us, find the value of y for which PQRS is a parallelogram. So I see that my algebraic expressions here are on my sides. And I know that opposite sides are going to be congruent in a parallelogram. So I know that y must equal x plus 2. Well, that doesn't help me very much because I don't know what x is. But I can also set up another equation. So we're just going to kind of like put that on hold for right now. And we're going to set up 3x minus 5 equals 2x plus 1. I'm going to move my 2x, move my 2x. I get x minus 5 equals 1. Add my 5. X equals 6. Okay, so now that I know that x equals 6, I can take that and I can plug it back in right there, and I get y equals 6 plus 2, which is 8. So the question said, find the value of y for which PQRS is a parallelogram. Okay, my answer is y equals 8. In the next problem, it says, is the figure a parallelogram, why or why not? Okay, so we have to think back to those properties that we just learned, those theorems that we just learned. In this picture, I see a couple of things. First of all, here I have a set of congruent sides. However, I have a theorem that says both pairs of opposite sides must be congruent. Here, I have this pair congruent, but I don't have AD and BC. So that's not going to work. So the other thing I'm going to look at is I'm going to look at these angle marks here. I have 50 and 130. Okay, so I know that 50 plus 130 is 180, so those are supplementary, but my theorem says that an angle must be supplementary to both its consecutive angles. So I do not know that this is a parallelogram. It might be, but I don't know that it is. So I'm going to put no, it's not a parallelogram. And that's that fancy symbol for parallelogram, so you don't have to write that word a million times. Because not both opposite sides, sorry, I'm going to stick that word opposite in there, opposite sides congruent, and not both consecutive angles are supplementary. So no, I don't know that this is a parallelogram because I don't have both opposite sides being congruent, and I don't have both consecutive angles being supplementary. So I do know some information, it's just not quite enough. So here I have 3 problems for you to try. You need to go through this first problem. It's asking what value must y be in order for L, M, and P to be a parallelogram. For 2 and 3, it wants to know, is there enough information given to prove that ABCD is a parallelogram? If there is, explain why. If there is not, you also need to explain why. And the last thing I have is I have one more problem for you. It does say buzzer beater up here, but I'm going to cross that out. It's like a little bit of white out here. Get rid of that. And we're going to make this another you try problem. We're going to do this last one. So this will be you try number 4. It says, your friend says if a quadrilateral has a pair of opposite sides that are congruent and a pair of opposite sides that are parallel, then it is a parallelogram. What is your friend's error? And explain. So I need you to give me an answer to that problem as well. So that's all that we're going to go through in this video. We'll be going through some of these things in class tomorrow. Please make sure that you're scaling yourselves on your learning objectives, and make sure you're ready in class tomorrow with your notes to begin working on problems. Have a great night. I'll see you tomorrow in class.